Here, do that. Okay, you see what I see, don't you? The fact that we are going to infinity, you can't go to infinity. It just doesn't work. I tried. So what we're going to do instead is pretend to go to infinity by evaluating a limit as b approaches infinity. That's what we do. We are going to do that because, again, you can't go to infinity. And 0 to b dx x squared plus 1. All right, notice the dx is the numerator. Doesn't change anything. It can be off to the side. It can be the numerator. Now, I need to take the antiderivative of this if you are thinking that we should use u substitution. Let's follow that train of thought. Please don't write this. X squared plus 1 du equals 2x dx. I don't have an x. I have 1 dx. It's not going to work. No way you're going to get this to work with u substitution, the standard way that we've been doing it. So this is the exception. You've seen this a few times before, but you need to be able to identify it. If you didn't, don't panic. This is a perfect square of a function, and this is the perfect square of a function. Again, it doesn't have to be a perfect square, but it could be. And I would like to think that you remember this formula. The integral of du over a squared plus u squared, this is in a slightly different order than that. This is the way most textbooks do it, is 1 over a arctan of u over a, and then plus c. This is going to be a definite integral, so I will not need a c, but this structure is this, which means, switching colors again, let's go green. No, red. This means that u, being the function, is x. So u is x and du is dx. And a is 1. A squared is 1, so a is 1. And u squared is x squared. So we have everything we need to go ahead and just turn this into the arctan that it is. So I'm not going to do a whole bunch of rewriting. It's all ready to go. So let's just do it. Don't forget your limit. If you want to save it to last, at least leave some space for him. Limit as b approaches infinity of, okay, everything that's about to happen is going to happen from 0 to b, not 0 to infinity. We can't go to infinity, but you can get there-ish with a limit. We can evaluate it. I don't have symmetry on my parentheses there. All right, we'll fix that. So antiderivative of this guy right here is this structure, which breaks down like this. So it's 1 over 1. Well, that's pointless. Don't put that. Arctan of u over a, so x over 1. That's just x. So arctan x. Done. Well, done with that step. Now we're going to plug in a b, we're going to plug in an infinity, we're going to find a limit. It's going to be fun. By the way, if you want to know what this looks like, graph it. It's a really cool graph. It looks, well, I draw it, but I draw it wrong. Yeah, let's talk about it. This denominator is never negative, so everything's going to be above the x-axis, and it's got this little kind of bulge in the middle at 0. Anyway, fun. Limit as b approaches infinity of, and then we'll do our, what's it called, that really important thing? Fundamental theorem of calculus. That's what it is. What's that really important thing that my career is built around? Oh, the fundamental theorem of calculus. Arctan of 0. There we go. This requires some knowledge of the unit circle. Okay. So if b was infinity, I would need to know what arctan of b would be. So what is the arctan of infinity? Like, whoa, what? What? Huh? Okay. Unit circle time. Let's erase a formula that we don't need anymore for the rest of this problem. Unit circle, and we're going to do the obscure stuff. Wow, that unit circle is not centered, but we'll deal with it anyway. I'm going to, this is a unit circle that looks like a flattened unit egg that is slightly off center, and this unit circle, on it, I'm going to put tangents, not sines and cosines. That's the obscure part. So tangent of 0 is 0. Tangent of pi over 2 is undefined. So I would say it's undefined, but if you want to get real technical about it, it's infinity, depending on which side you're coming from. Let's go with this from a different perspective. The graph of tangent, which you may or may not have seen before, hope you have because it's fun. The graph of tangent has a vertical asymptote at negative pi over 2 and positive pi over 2, and the graph itself looks almost cubic in that regard, but it does keep repeating. It's cyclical, or periodic, I should say. It does like this. But we're only going to be focusing on that. So as b approaches infinity, which has no choice but to approach infinity, approach infinity from one direction. As we're going up towards it. As we're going up towards it, we're approaching this x value right here, which would be pi over 2, which is the radian measurement here. Okay, let's back up one more time. I've always had to explain this one 2 or 3 different ways. Arctan is a question, and the question is, at what angle will my tangent be this? At what angle is my tangent 0? 0. My angle is 0 degrees, 0 radians, it's 0. So if you want to jump ahead, minus 0 for that term. Okay, here's the question. At what angle is my tangent infinity? Here, pi over 2. Pi over 2. Pi over 2. Pi over 2. Half a pi. Sounds delicious.